This question comes from Sam, who asks, what if time moved differently in space? At first, it sounds like science fiction. But according to Einstein's theory of relativity, it's real, and the effects are mind-bending.
Time as we experience it on Earth is actually just one reference frame. In space, time is relative. It can speed up or slow down depending on two things: gravity and velocity. The stronger the gravitational field, the slower time passes. And the faster you move relative to another observer, the slower time seems to pass for you. Let's start with gravity. Imagine you're near a black hole, one of the densest objects in the universe. Its gravity is so intense that it warps space-time itself.
A minute for you near the event horizon might equal hours, years, or even centuries for someone far away. This effect, called gravitational time dilation, has been confirmed by experiments near Earth's gravity as well, although the differences are tiny here.
Now consider velocity. Astronauts aboard the International Space Station experience a slight time dilation because they orbit Earth at about 28,000 kilometers per hour.
Their clocks run a tiny bit slower than those on Earth, just milliseconds over months, but the effect is measurable. If you could travel close to the speed of light, however, the effect becomes dramatic. A journey that feels like a few years for the traveler could mean centuries have passed on Earth. So what would happen if humans lived in regions of space where time moved differently? Colonists on a fast-moving spaceship or near a massive planet might return home to find centuries had passed. Your friends, family, and civilizations could be completely different. It's not just science fiction. It's a real challenge for future interstellar travel. Time moving differently would also affect aging. A human near a strong gravitational field would biologically age slower compared to someone in weaker gravity.
In theory, someone could travel to a massive neutron star, spend a few years there, and return to find Earth had advanced by decades or more.
This creates fascinating possibilities and serious complications for human exploration and colonization of space.
It doesn't stop there. Time dilation affects communication and coordination. Signals sent from a spaceship moving close to light speed would be delayed when received on Earth. A message that seems instant to astronauts could arrive centuries later for those back home. This would completely alter how we think about planning missions and interacting across vast distances. Even space habitats orbiting massive planets or stars could experience slightly different rates of time than Earth. Imagine two space stations, one near Jupiter's gravity well and another farther away.
Clocks, electronics, and even human perception would drift ever so slightly relative to each other. Over decades, those small differences could accumulate into significant gaps. The philosophical implications are huge. If time is relative, our experience of history, causality, and aging is not absolute. Two people in different gravitational or velocity environments might live through the same events in completely different orders or perceive them differently. The universe is not a single timeline, but a web of timelines, all flowing at different rates.
This relativity of time also means that space travel and human expansion into the cosmos will have to account for these differences. Colonizing other star systems isn't just a matter of distance. It's a matter of synchronizing human experience with the rhythm of the universe itself. 1 century on Earth could be just a decade for astronauts traveling near light speed. Generations could pass differently depending on where you are in the cosmos. In essence, living in space means living with time as a flexible dimension.
A future where humans explore distant galaxies might involve entire communities aging at different rates, communicating across centuries, and witnessing a universe that stretches, warps, and bends around them.
Time as we know it on Earth is not universal. It's a personal, relative experience shaped by speed, gravity, and motion.
So next time you look up at the stars, remember, out there, time might be moving differently.
A minute for you might be a century for someone else, and the universe itself could feel like a slow, stretching dream. Space isn't just vast, it's temporally strange, and our understanding of life, history, and existence depends on where we are in it.